So section 5.4, as I just mentioned, does not have anything new to it. What it does have is creates a system of what we should look at when we go to factor. Okay, so it's just a strategy. It's just systematizing the stuff that we've already seen. So as far as in this class and what we have now in this unit, what's going to come in the next unit, this is kind of your approach when you look at something that needs to be factored. Okay, and we've done all these things, so I'm just writing this down. The first thing is you should always look to see, or you should ask yourself the question, is there a common factor? Okay, so that's first. That was the first section we talked about in this unit. Okay, is there a common factor? If there is, take it out. You want to deal with the smallest numbers possible. The instruction that I give you is just going to be to factor completely. So at some point, it's got to be factored out. You might as well do that first. Then the second thing you do deals with how many terms there are. Okay, and what we know, we just know some basics of factoring. You know enough to get you through the next couple classes. If you are going to pre-calculus after college algebra, you'll talk about some other factoring techniques that'll help you out. But for now, this is what you need. So it just depends on the number of terms. So first, if there's 4 terms, what did we say? What's the only way that you have to approach something that has 4 terms? To do what? Grouping. Yes, the first section, to factor by grouping. Okay, so if it has 4 terms, if it is going to be able to be factored, because not everything with 4 terms can be, but if it's going to be factored, then you use grouping. That's your clue. Okay. I'm trying to make this as straightforward as possible. When you get to this test, when you come back on Thursday, hopefully, if you remember just the basics of what we've done, it should be nice and super straightforward. The next thing is if there are 3 terms. 3 terms, I'll kind of subcategorize this. If the leading coefficient is 1, then what we did is we unfoiled. We just wrote the 2 sets of parentheses and we said, okay, here's the firsts. And then what are the lasts that add up to the middle? And then if the leading coefficient was something else, what I showed you to do, it's not what you have to use, but what I showed you to do was called the AC method, or the grouping method is what I'll call it right here. And I believe I was super clear about this when we went through it. If you came into this class and you love the factor and you have another method that works, then use it. Okay, I'm not asking you to change. I just gave you something in case you're not super confident or in case you don't have a way. Okay, so that's the way that I showed you. And then the third thing, if there are 2 terms, there are only a couple of things that we know how to factor that have 2 terms. It's either a difference of squares, and please remember, for squares, it has to be a difference, no choice. You can't factor a sum of squares. But where we can factor a sum is if we have cubes, so a sum or difference of cubes. So your factoring system goes like this. Is there a common factor? If there is, factor it out. If there's not, step 2, how many terms are there? And then the way you approach the problem is just based on how many terms. And then lastly, the third step is just to make sure that you factor completely. So once you've factored, if any of the factors you get can be factored again, then do it. Okay? If not, then you're done. So I've just got 4 problems here just so that we can go through the steps. Okay, hopefully these aren't anything too big of a deal, but we'll see as we go. So what I would like you to do is exercise 1. Factor that polynomial right there, and then we'll talk about it. All right, so step one on this problem. Is there a common factor to those terms? Yes, what is the common factor? 8, yes, that's the greatest common factor for sure. So we're going to factor out an 8 here. When I factor out the 8 out of 8x squared, so please excuse my questions if you find them super basic, but this is review. Okay, this is 3 out of the 5 sections that's going to be on your test. So what's left when I factor out the 8 out of the first term? X squared, yes. Plus, what's left when I factor the 8 out of 8x? X, yes. Minus, and what's left when I factor the 8 out of 96? All right, there you go. Perfect. You're doing a great job so far. So what's left here has 3 terms. So I'm going to try to factor it. Since the leading coefficient is a 1, I'm just going to unfoil and we'll see if this works. Now, again, I made the promise to you on the test, everything will factor. Okay, there's nothing, you're not going to look at something like that and it's going to be prime. Okay, so I'm trying to teach you how to factor and get comfortable doing that. All right, so my firsts have to give me x squared. Well, the nice thing about the leading coefficient 1 is what's the only choice? X, 1x times 1x, yes. What are the signs that I'm going to use in the middle of both these binomials? Negative and positive. How did you know that? You're 100% right. My lasts multiply to give me a negative 12. So that means the signs have to be different. Positive, negative, negative, and positive. The order absolutely does not matter. And what are the 2 factors of 12 that are going to be 1 apart? 3 and 4. Which one gets the joy of being the positive one? The 4 does, because it has to add up to a positive 1. The positive wins. And so we've got positive 4 and minus 3, and there it is. Nothing else factors. Neither of those binomials, those things with 2 terms, can be factored any further. So we are done with that problem. Go right next door to exercise 2. Same thing. Factor that completely, please. All right, on this second problem, is there a common factor that I can take out of all of these terms? Yes, what is it? Okay, there's a 5, 10, 35, and 75 all share a 5. I'll agree with that. Is there anything else? Yeah, an x. I've got an x cubed, an x squared, an x. You can always take the smallest power of x when they all share. So 5 and x. All right, so when I take out the 5 and the x, what's left from the 10x cubed? 2x I started with 3 x's. I took 1 out. So how many x's are left? 2. 2x squared. Okay, 35x squared. I take out the 5x. What's left there? Okay, 7x, appreciate that. 35 divided by 5 is 7. X squared divided by x is x. And then lastly, negative 75x, I factored out the 5x, so I'm left with what? Negative 15, and that's it, no more x. Probably I could put this, let me write this parenthesis a little closer so it looks neater. Okay, so now this one, this trinomial has a number in front of the x squared, so I'm going to employ the grouping method. And just so that I don't forget later, I'm just going to take this 5x, I'm going to put it down here. It's part of the answer. If you want to get the problem 100% correct, make sure to include all the factors in your answer. And now what I'm going to do is what's called the AC, or the grouping method. I'm going to take the 2 times the negative 15. That gives me negative 30. And I ask myself a similar question that we just asked at about the problem to the left. Is what are the 2 factors of negative 30 that are going to add up to 7? Well, first, what are the signs? I'm going to use a what and a what for this one. A negative and a positive. Since it's a negative 30, I'm going to use one of each. So a positive and a negative, or a negative and a positive. The order absolutely doesn't matter. And what 2 factors of 30 are going to be 7 apart here? Yeah, 10 and 3. Now, again, it doesn't matter what order your factors are in, but the 10 does have to be positive and the 3 does have to be negative. Okay, so if you have a negative 3 first and it's positive 10 second, absolutely is fine. So now I'm going to take these 2 things and I'm going to use them to split this, this polynomial with 3 terms into a polynomial with 4. So I've got 2x squared plus 10x minus 3x minus 15. And now I'm going to group. That's the whole point to this right here, is to use grouping. Out of the first 2, I can take a 2 and an x. 2x squared, I factor out 2x, leaves me x. 10x, factor out the 2x, leaves me 5x, or not 5x, sorry, just the 5. So pretend you don't see that smudge right there. And then I have negative 3x and negative 15. Well, I do notice both of those terms are negative, so that's a clue to take the negative out. And 3x and 15 both share a 3. Negative 3x, I factor out the negative 3, I'm left with x. Negative 15, I factor out the negative 3, and I have plus 5. Notice my grouping did work. I have the exact same thing in both sets of parentheses. That is my clue. And so what I do now is I factor that out. Okay, so factoring by grouping is just factoring out the common factor twice. So I take out that x plus 5. It's not x plus 5 squared. That's a common typo students make. There's not 2 of them. Each of these just has 1. So I factor out 1. Then from the first term, I have 2x left. From the second term, I have minus 3 left. And there's my fully factored expression. If you have a question, if something doesn't seem clear, please bring it up. Let's talk about it while we're reviewing before we go on to our last section. Exercise 3 is next. All right, step 1, is there a common factor to these 2 terms in x to the 4th minus 81? Common factor, yes or no? I hear a couple mumbled no's, so I'm going to go with that. You're right. No common factor. So this has two terms. Is this binomial here, is this a difference of squares, or is it a sum or difference of cubes? Squares or cubes? X to the fourth, that is not a cube because there's 4 of them. 81 is also not a cube. So 3 times 3 is 27, and 9 times 9 times 9 would be large. So this is not going to be a cube. Okay, so this is a difference of squares, only option. And I gave this problem because we did one just like it in class. And I also told you it's one of my favorite problems. So I just wanted to keep it top of mind because there is going to appear one of these on the test that you take on Thursday. So then spoilers. So here we go. When I do my difference of squares, x to the fourth is going to be what two things multiplied by themselves? Yeah, you guys are not lively today. You should have some sugar or caffeine before coming in. Okay, 81. 81 is what two things multiplied by themselves? Okay, 9 and 9, and then yes, you're going to do a plus 1 or minus the other, and the order does not matter there. And this is where the factoring completely comes in. And this helps me discern that you remember that you can't factor a sum of cubes. So the x squared plus 9, because of that plus between that, you cannot factor that. So I've got x squared plus 9. But the x squared minus 9 is another difference of squares. That's why I like this problem. Okay, so x squared is going to be x times x. 9 is 3 times 3. Plus 1 minus the other, or minus and plus. Those are the 3 factors you should have. All of us should have the same 3 factors. Okay, if you got something different, then you should ask a question. One more problem, and then we are going to wrap up this very quick overview of where we've been as far as factoring. So exercise 4, go ahead and do that one, please. All right, so exercise 4, notice there's no common factor. 27 and 1,000 do not share anything in common. We've got 2 terms here. This one, is this a problem that involves squares, or is it a problem that involves cubes? This one's a cubes problem. Okay, so I just want to make sure we remember this special factoring today. So here goes. When we do a sum or a difference of cubes, it's the same process. There's going to be 2 factors. One factor is going to be a binomial, meaning 2 terms. The other factor is going to be a trinomial, meaning 3 terms. So somebody help me. What are the terms for the binomial? Anybody remember this? The cube root of everything. Yeah, that sounds great. So 27z cubed is what times itself 3 times? Okay, a 3 and a z. That is true. And then negative 1,000. Negative 1,000 is what times itself 3 times? Yep, there you go. That's the key bit of information. The rest in the trinomial part is just related to that. So again, the way that I like to do this, and if you found a different pattern and a different way of doing this, by all means, help yourself to that. But I need my firsts, my whatever's here times 3z should give me 27z cubed. Another way of thinking about that is division. 27z cubed divided by 3z leaves me my first over here. Either way you slice it or dice it, it is 9z squared. I'm going to skip the middle term for the moment, and I'm going to go right to the lasts. Negative 1,000 divided by negative 10 is plus 100. And then that middle term, this is kind of the hardest part to remember. The middle term is always what you get when you multiply the two bits of the binomial, the 3z times the negative 10, and that's negative 30z. And then you change the sign, so it becomes plus 30z. And there is my factored expression. One more time, I'm just going to remind you that this trinomial in your sum or difference of cubes can't be factored. So you can go ahead and rest easy that you're done.